yesterday we played with Play-Doh, and we looked exclusively at cross sections that had a square base. So what I had in the notes was we looked at a loaf of bread, you slice a loaf, and that's the slice, and what you see inside the loaf is in fact a cross section. Just to recap what we did yesterday as well is we looked at the volume of one slice, and then we allowed calculus to happen, where if we can then take infinitely many slices, that will give us the exact volume. So today, in this one, let's look at a different cross-section. Let's look at a rectangular cross-section. It says, find the volume of an object whose base is bounded by the x-axis, the vertical line x equals e, and the curve y equals the natural log of x, with rectangular cross-sections perpendicular to the x-axis. The rectangular cross-sections are 4 times as tall as the given base at any x value. So let's go ahead and make a sketch of the region to know what we're even talking about. So y equals the natural log of x. You're supposed to know what that looks like. It has a 0.1 comma 0, comes up like this. X equals e. You are supposed to know an approximation for e. What is it roughly? 2.7. Okay, that's awesome. 2.7. So we're going to make a vertical line. This is x equals e. So, and enclosed with the x-axis, so I'm looking at this particular region. And I want to take rectangular cross-sections that are perpendicular to the x-axis. So the width is going to be dx, because I'm going to let dx get infinitely smaller, smaller, smaller. And so this piece right here is the base of my rectangle, and that distance is y. So the base of the rectangle is y, and it says it's 4 times as tall. So area of a rectangle is base times height. So this is y times 4y, or 4y squared. So when you're doing these problems, I don't expect you to immediately know what to do or how to do it. That is okay. But what I expect you to do is keep asking yourself questions. What do I know? What could I find out? How could I proceed? Just don't stop asking questions of yourself. So I'm going to look back at the problem, and because the cross sections are perpendicular, I want this to be in terms of x, because it's dx. So I need to go back to my area and say, all right, well, what else do I know? I know that y is the natural log of x. And what we learned yesterday is that volume is equal to the integral of the area times dx. This is when you are doing a cross-section, volume by cross-section. So let's plug in what we know. What would be my limits of integration? Good job, 1 to e. My area is 4 times the natural log of x squared dx. This is not one we can do by hand. So grab your calculators and let's get the numerical integral. All right. I got 2.873. For those of you that got there, did you get the same thing? Awesome. All right. So that is a rectangular cross section. Now, if you notice on this one, it said the rectangular cross sections are 4 times as tall as the given base. You have to be told something about the height of the rectangle because it's not a square. Or if you have the square, you know it's side times side. So you need other information if it's a rectangular cross section. All right, so now we're going to take it up a notch. It says an object has cross sections that are squares perpendicular to the y-axis. So now I'm taking these cross sections perpendicular to the y-axis. The base of the object is bounded by the x and y axis, x equals 1, and f of x equals x cubed plus 1. The graph is shown. Find the volume of the object. So I want you to notice I've done where I had us come up with the sketches, and then I've also given you a sketch. I cannot predict what they're going to do on the AP exam. Sometimes they give you a sketch, and sometimes they don't. So we're doing, enough of both types so that you're comfortable. So what's happening here is I really have 2 regions. I have this, we're going to call it region 1 and region 2. You understand that if I am doing square cross sections, this ends up creating a cube that's 1 by 1 by 1. So my first region, that's just a cube, okay? So that's nice. Now we're going to look at this second region and try to come up with its volume. I want the cross sections to be perpendicular to the y-axis, so I have widths that are dy. But now I need to find the distance of each slice. And that distance is not x. It's been happening that way almost every time, that it was just x. This distance is not x. I'm going to give you a minute at your tables, and I want to see if you can come up with what is this distance here. Okay, go ahead and discuss. All right, so if I were to take a slice all the way across, that full distance is bounded by the line x equals 1. So that is 1. This piece here is actually x, because that is the distance to the curve. So that I'm asking you, what is this distance inside this region then? Yeah. Good job. Okay, so a side length of our square is 1 minus x. Okay, this is tricky. Let me talk about this one more time. So the whole distance from the y-axis, remember we're going perpendicular to the y-axis, all the way to this boundary is 1. Well, from the y-axis to the curve is a distance of x. I've moved to the right x units. So then if I want this piece, that's 1 minus x. Yeah, Sam?
Is this just the right minus the left again?
Yes, good job. Yeah, it is like right minus left. That's a great way to think of that. So then my area is going to be 1 minus x squared. The problem is my volume is the integral of the area with a dy. So I've got a problem. But it's a problem we know how to fix. So I'm going to take my curve, y equals x cubed plus 1. I'm going to subtract 1 from both sides and do the cube root. That is going to give me x. So I've got my 1 from region 1, that was my cube, plus. Now what are the limits of integration on this region 2, if I'm doing it in terms of y? It's 1 to 2, right? It's 1 to 2. It's not 0 to 1 because I'm doing this on the y-axis. And this region starts where y is 1 and it's going up to where y is 2. So then my area was 1 minus x, which is the cube root of y minus 1, that quantity squared dy. All right, so this is great. I'm trying to go really slowly here so that we can think and process. So remember, a side length is 1 minus x. The area would be 1 minus x times 1 minus x. X is the cube root of y minus 1. So I'm just plugging that in, but replacing x with what x equals so that it's in terms of y. Go ahead and just do this one on your calculator. All right, so that integral is probably spitting out 0.10000, a whole bunch of zeros. And then don't forget about the cube, so my volume would be 1.1. All right, any questions on that one?